guys, it's me, Bianca, and welcome back to another episode of MadSci. So for this episode, we are going to tackle about another property of engineering materials, and that is thermal property. As an overview, we are going to discuss heat capacity, thermal expansion, thermal conductivity, and thermal stress. So without further ado, let's start.
Thermal properties describes the response of a material to the application of heat.
Sa solid, kapag nagkaroon ng absorption ng energy in the form of heat, yung temperature ng object na yon tataas. At yung dimension niya mag-i-increase. Kapag meron tayong temperature gradient o ang isang object ay mas mainit kesa sa isa, yung transfer of heat ay mula sa warm object papunta sa cooler region.
The important thermal properties are heat capacity, thermal expansion, and thermal conductivity. First important property is heat capacity.
Solid material, lagi natin tatandaan na kapag nagkaroon ng temperature rise o pagtaas ng temperature, nangangahulugan yon na nagkaroon ng absorption of energy.
Heat capacity represents the amount of energy required to produce a unit temperature rise.
Ang heat capacity ay isang property na kung saan sinasabi niya na ang isang material ay merong abilidad na mag-absorb ng heat mula sa external surrounding niya.
In mathematical terms, the heat capacity, or denoted as capital C, is expressed as the energy required all over temperature change. Ordinarily, heat capacity is specified per mole of material. Its unit is joules per mole Kelvin.
Ang heat capacity usually na-associate siya sa specific heat, kung saan specific heat ay dinodenote sa lowercase c. Ang pinagkaiba nga lang nila, ang heat capacity is amount required para tumaas yung temperature mo ng isang unit, kung saan naman ang specific heat is heat capacity per unit mass.
Specific heat has various units. Some of them are joules per kilogram Kelvin and calorie per gram Kelvin.
Heat capacity, may dalawang paraan para ma-measure siya, kung saan nakadepende yung pamamaraan na yon sa environmental condition kung saan nagtatransfer yung heat.
One is the heat capacity while maintaining the specimen volume constant, denoted as capital C sub V. The other is the constant external pressure, which is denoted as capital C sub P. The magnitude of heat capacity with constant pressure is almost always greater than the heat capacity with constant volume. However, this difference is very slight for most solid materials at room temperature and below. But how do heat capacity changes with the respect of change of temperature? Firstly, as the temperature increases, so does the heat capacity. For solids, it reaches a limiting values of 3R, where 3R is the gas constant with values of 8.31 joules per mole Kelvin. In an atomic perspective, the energy is stored as atomic vibrations. The way it behaves is that as the temperature gradually increases, the average energy of the atomic vibrations also increases. Now, if I'm going to compare the specific heat of materials, then we have three groups of materials, which are polymers, ceramics, and metals. What's interesting here is that polymers have much higher specific heat, followed by ceramics, and below them are metals.
Pero bakit nga ba ang specific heat ng polymers ay mas mataas kumpara sa iba? Ang main reason doon ay dahil sa covalent bonds ng polymers. Yung covalent bonds kasi na yun, pinipigilan niya yung atoms na magkaroon ng exchange of electrons. Hindi katulad sa metals. Sa metals kasi, merong free electrons yung mga atoms niya. Kaya mas madali para sa kanila ang magkaroon ng exchange of electrons. At kapag nangyari yun, yung pagtaas ng temperature mas bibilis. At dahil doon, yung heat capacity mas mababa kumpara sa polymers.
Second important property is thermal expansion.
Now let's all talk about thermal expansion. As you know, temperature of a solid material is a measure of its potential energy.
Most solid materials expand upon heating and contract on cooling. Heating to successively higher temperature rises the vibrational energy. Thus, as the vibrational energy increases, the interatomic separation increases from R0 to R1 to R2 and so on. The change in length with temperature for a solid material may be expressed as the final length minus the initial length all over the initial length. It is equals to the linear coefficient of thermal expansion, or denoted as alpha, times the change of temperature.
Linear coefficient of thermal expansion is a material property kung saan siya yung nag-i-indicate kung hanggang saan mag-expand yung material mo once may presence ng heat. Ang unit nito ay reciprocal ng temperature. Kumbaga, degrees Celsius raised to -1 or degrees Fahrenheit raised to -1.
Following this definition, we will be able to have the values range of materials in the units of the reciprocal of degrees Celsius. Above all the three materials, polymers has the highest range of linear coefficient of thermal expansion.
Heating or cooling of a material affects all the dimension of a body. At kapag nangyari yon, magkakaroon ng change of volume. Ang change of volume na ito with respect to temperature can be solved with this formula.
Delta V all over V sub 0 is equals to alpha sub V times delta T, where A sub V is the volume coefficient of thermal expansion, V sub 0 is the original volume, the delta V is the change in volume, and delta T is the change in temperature. Ngayon, kung ipagkukumpara ulit natin ang linear coefficient ng tatlong materials, mapapansin natin ang merong pinakamataas ay ang polymers, sinundan ng metals, at huli naman ang ceramics. Pero bakit nga ba polymers ang may pinakamataas na value ng linear coefficient? Ito ay dahil sa kanilang weak secondary bonds. Linear and branch polymers expand more because the secondary intermolecular bonds are weak, and also there is a minimum cross-linking. Last important property, thermal conduction.
Ang thermal conductivity ay isang phenomena na kung saan ang heat ay nagtatransfer mula sa high temperature region papunta sa low temperature region. Ito rin ay isang property na kung saan sinasabi niya na ang isang material ay may abilidad na makapag-transfer ng heat.
Thermal conductivity is best defined in this formula, where Q denotes the heat flux or heat flow per unit time per unit area. K is the thermal conductivity, and dT over Tx is the temperature gradient through the conducting medium. Negative sign beside K indicates that heat flows in the direction of the decreasing temperature. Let us proceed to the mechanism of heat conduction in the three materials, which are the metals, ceramics, and polymers. Now, let us go first to metals. In metals, we have three things to remember. Firstly, metals are extremely good conductors of heat because relatively large numbers of free electrons exist that participate in thermal conduction. Second thing to remember is that the purest form of metal will have the highest conductivity than the alloy form. And last thing that we have to remember about metals is that in the alloy, different atoms will have different electron affinity. Thus, the movement of excited electrons becomes hard. Now let's proceed to ceramics. In terms of their thermal conductivities, we also have to consider three things. Firstly, they are thermal insulators, as they lack large numbers of free electrons, which is contrary to the metals. Secondly, the room temperature thermal conductivity of ceramics ranges between approximately 2 to 50 watts per meter Kelvin. Lastly, amorphous ceramics have lower conductivities than crystalline ceramics, as atomic structure is highly disordered and irregular. And now, for the last thing to discuss in thermal conductivity, we have polymers. And in polymers, we have to remember two essential things. Firstly, thermal conductivities for most polymers are of the order of 0.3 watts per meter Kelvin. The energy transfer is accompanied by vibration and rotation of the chains of molecules. Then, last thing to remember is that the magnitude of thermal conductivity depends on the degree of crystallinity. Highly crystalline and ordered structure means effective coordinate vibrations, thus higher thermal conductivity. Thermal stress.
Thermal stress, pwede mo siyang makonsidera bilang isang consequence. Kung saan, consequence siya kapag nagkaroon ng pagbabago sa temperature. Pwede itong makakos ng isang fracture o di kaya naman ng undesirable deformation sa isang object.
The two prime sources of thermal stresses are restrained thermal expansion or contradiction and temperature gradient established during heating or cooling. In mathematical interpretation, we have this formula, where E is the modulus of elasticity and alpha is the linear coefficient of thermal expansion.
Katulad ng sinabi ko kanina, ang thermal stress pwede siyang makaproduce ng isang fracture. Ang tawag sa fracture na yon ay thermal shock. Kapag nagkaroon ng thermal shock, usually dahil yon sa mabilis na pagbabago ng temperature.
Because ceramic materials are brittle, they are especially susceptible to this type of failure. Thermal shock resistance is the capacity of a material to withstand thermal shock. It is proportional to the fracture strength and thermal conductivity, and is inversely proportional to both the modulus of elasticity and the coefficient of thermal expansion. Let's have some practice problem about thermal stress. A brass rod is to be used in an application requiring its end to be held rigid. If the rod is stress-free at room temperature, which is 20 degrees Celsius or 68 Fahrenheit, what is the maximum temperature to which the rod may be heated without exceeding a comprehensive stress of 172 megapascal? Assume a modulus of elasticity of 100 gigapascal for brass. With the use of thermal stress formula, we can solve this problem, where the stress of 172 megapascal is taken to be negative. Also, the initial temperature is 20 degrees Celsius, and the magnitude of the linear coefficient of thermal expansion from table is 20 times 10 raised to negative 6 degrees Celsius. Thus, solving for the final temperature, TL yields 20 degrees Celsius plus 86 degrees Celsius is equals to 106 degrees Celsius or 223 degrees Fahrenheit. Before I end this video, let me first recall to you the important terms and concepts that were mentioned. So first is heat capacity, specific heat, thermal shock, linear coefficient of thermal expansion, thermal conductivity, and thermal stress. If you want to further this study, you can go ahead and find Material Science and Engineering, an introduction by William D. Callister Jr.
That's all for this episode. I hope you guys learned a lot. So see you next episode. Bye!